Hello, my dear friends. Am I audible? Yes, I'm audible. Yeah. So, my dear friends, let us start. So, today we are going to talk about the electric field, the basic concepts and basic formulas of electric field. Okay. So, that is very, very important for NEET physics, right? Obviously, because there will be so many questions from electrostatics based on electric field. Okay. And in some other chapters, also electric field may be used. So I am saying basically the electric field is very very important topic. So I am not going in very much detail, but I will discuss the basic formulas and basic concepts of electric field. Okay, and you are going to enjoy it. Okay, and at the last I will just increase the difficulty level from easy to difficult. We will move. Okay, so that all type of students can learn it very well. Okay, so um let us start. So at first I would like to welcome you all. So welcome to Unacademy. Unacademy is the India's largest learning platform where you can prepare for the various competitive exams with the help of the top educators of the country, with the quality content and great learning experience. And I am available here to help you to crack NEET UG. So let's crack NEET UG, my dear friends. Let me introduce myself. My name is Rahul Dagariya. I have been teaching physics since 5 years in the various reputed institutions of India. Till now, I have mentored to the thousands of aspirants of NEET and IIT JEE, and now I am available here to help the students of the country to learn the concepts of physics for NEET UG with the best notes and best examples. So, you are going to enjoy with me. So next I will talk about our new anthem. Okay, so that is our motto, we can say. So we want you to crack NEET UG with the India's largest learning platform, Unacademy. So if you wanna crack NEET, then get the plus subscription and access to the unlimited live and recorded courses from India's best educators. Yes, my dear friends, as I said, you will get the India's best educators on Unacademy. If you did not download the Unacademy app yet, please go to Play Store and type Unacademy Learning App and download it. Okay. After that, what you need to do? You need to get the plus subscription. You need to get the Unacademy subscription. So what you will get if you will buy the Unacademy subscription? So let us see. You'll get the daily live classes. Okay, daily live classes means the teachers are delivering the live lectures. Okay, and you can chat with your educator, you can engage in the discussion, you can ask your doubts, you can discuss your answer polls, and you are going to have a lot of fun, my dear friends. Okay, so very much beneficial, right? You don't need to move to one place to another place. Just sitting at your home you can attend the live lectures, right? Okay, after that, live test and quizzes. Yes, my dear friends, you can evaluate your performance with our regular mock test and quizzes, right? Without evaluation of without evaluating your performance, you cannot understand your learning. Okay, means you cannot understand how much you are learning and how much you are forgetting. Okay, whether you are able to apply your concepts or not. Okay, so that is the main thing, or you will get its detailed analysis, my dear friends. After that, the structured courses, my dear friends, you will get all three subjects: physics, chemistry and biology. Biology include both zoology and botany, right? And you are getting the complete syllabus with the help of India's top educators, so you can choose your educator of your choice, right? Yes. Next I will talk about the unlimited access to the live and recorded courses, my dear friends. If you miss the live lecture, then you can watch its recording also. Okay, let's say you did not understand in one chance, then you can watch it again and again repeatedly, right? Doesn't matter, there is no limit. Okay, so these are the benefits. After that, you will get the test series also, so you will enjoy a lot, my dear friends. Next, free live classes are available on YouTube, right? As you are watching my lecture now, and you can experience it in a better way at Unacademy platform. For that, you need to get the Unacademy subscription. Okay, our top educators are mainly from IITs, NIDs, AIMS, and reputed MBBS colleges. And till now, they have produced very good ranks. Okay, top ranks they have produced. So definitely, such type of experienced educators are there on this Unacademy, right? platforms, so definitely you are also going to rock with them. So next I will talk about our subscription. Okay, so our subscription plans are available here. You can see this. Okay, the our subscriptions are available for 1 month, 3 months, 6 months, 12 months, and 24 months, right? You can see. So you will ask, chalo, let us talk about this. 1 month subscription is available for 6,000 rupees. 12-month subscription is available for 30,000 rupees, and 24-month subscription is available for 36,000 rupees. Are you getting, my dear friends? So I am saying ki 1 month for 6,000 and 12 months for 30,000 means it is equivalent to just 5 months fee, my dear friends. And 24 months, any 2 years course is available just for a fee equivalent to 6 months fee. Are you getting 6,000 for 1 month, you know? So 30,000 for 12 months and 36 for 24 months. So it is very less compared to any other coaching institute. But if you use my code Rahul D, okay, if you are using my code, then you will get the 10% discount. What you are getting? You are getting 10% benefit. So what you will get finally? So you will get this 1 month subscription for 5,400 rupees. Okay, after that 12-month subscription you will get for 27,000 rupees, and 24-month subscription you will get just for rupees 32,400 rupees. So my dear friends, if you will ask, so which one is beneficial, so I will say कि 1 month subscription you can buy, but it is not that much beneficial. Why? In 1 month hardly you can learn 1 or 2 topics, but in 12 months you can learn entire syllabus. In 24 months you can learn entire syllabus. Okay, so if you are giving your exam, NEET exam in 2021, then definitely you can buy 1 year or 2 year subscription. Okay, and if you are giving your exam in 2022, then you should buy this 2 year subscription. You can buy 2 year subscription, that will be more beneficial for you. Okay, so that's all I wanted to say. So use my code Rahul D, mind it, okay, and get the Unacademy subscription. So next I will talk about our today's topic, that is electric field. Okay, so let us talk about electric field. Electric field is the region. So what is electric field? So let us talk about this. Let us understand this basic concept first. After that we'll move to this whatever lines I have written. Okay, so this is a black background, so I need the yellow ink. So I am saying, let's say I have a positive charge, so let's say this is a Q charge. Okay, and around this charge there will be a region. Around this charge there will be a region. If I bring any other charge in this region, this charge will experience a force. This charge experience a force. So this region, you can see this region. So this region is called electric field. This region around the charge is called electric field. That's all. So you know gravitational, right? So around the earth, everywhere there is a region, right, in which any other particle comes, it will be attracted towards the earth. Similarly, around a charge, if any other charge is placed, then it will experience either a attraction force or a repulsion force. Means that region in which the another charge experience a force, that is called electric field. What? Electric field. That's all. So this is a simple thing I wanted to explain you, right? So you got it. Okay, so let's see what it is written here. Electric field is the region around a charged particle or a charged body in which if other charge is placed, it experiences an electrostatic force. That's all. Okay, now electric field intensity. What is electric field intensity? Actually it is just a value of electric field strength at a point. Are you getting? Means electric field is a region, but at a particular point what will be the value of electric field? Okay, that is called electric field intensity. Okay, so how to find electric field intensity, how to define it? Okay, so I am saying ki, let's say this is some charge Q. Okay, this is some charge Q, and around this is a region, okay, in which electric field is present. Now I am saying ki, let's say this is some point, this is some point P. Okay, here I am bringing, this is the source charge. Capital Q is the source charge. What? Source charge. After that I am bringing a small charge Q naught. What I am bringing? A small charge Q naught. Okay, so it will experience a force. It will experience a force. So this is called test charge. Q naught is called test charge. Okay, so remember, electric field is the force experience, electrostatic force experienced by a unit test charge. Unit test charge means I am saying ki the force experienced by this Q naught charge is K Q q naught upon r square, right? You know this formula. Okay, so what will be the electric field now? So that will be k q upon r square, because q naught cancel. So I will say force per unit charge at a point. Force per unit test charge at a point in an electric field is called electric field intensity at that point. That's all. Okay, so electric field intensity is just defined for a particular point. That's all. Okay, yes. So let us talk about this. Electric field intensity at a point is equal to the electrostatic force experienced by a unit positive point charge, both in magnitude and direction. So I'm saying a unit positive charge is there, right? So it is experiencing a force, right? So that is what electric field intensity at that point. That's all. Okay, so its formula I have written here. Let's say a charge q naught is experiencing a force F, then electric field intensity at that point can be defined as E is equals to F by q naught. Okay, so I have explained this formula. So remember, if electric field intensity is given, then how you will find the force? So F is equals to q naught into E. F is equals to q naught into E. Remember this formula. I think you can do it very well, right? Yeah, so this is the basic thing and all of you can do it very well. Okay, yes. So let's move. Let us talk about some important points very fast. We'll move, okay, because these are very easy but very important. So first point, it is a vector quantity and its direction is same as the force experienced by positive charge. Yeah, so it is vector quantity. All of you know force is a vector quantity, so field will also be a vector quantity. So this is charge and this is, let's say, test charge. So it is a unit charge. So both are positive, then the force on it will be in this direction. So hence I will say if there is no charge, there is a unit charge, then electric field intensity will also be in the same direction. Are you getting? So electric field intensity due to a positive charge is always away from the positive charge. Okay, and due to negative charge is always towards the negative charge. Okay, that's all. Yes, second point. So direction of field due to a positive charge is always away from it, while due to a negative charge is always towards it, right? So as I told, fadafad, let us talk about this. This is plus q charge, and at this point the electric field intensity will be like this. Okay, away from the charge. Okay, are you getting? After that, if there is a negative charge, then electric field intensity at this point will be towards the negative charge. Okay, that's all I wanted to explain you. So this is a very simple thing. Remember, mind it. Okay, so next point, the electric force on a point charge is in the same direction of electric field as the positive charge and opposite direction that of the negative charge. Actually, the same point I told. Okay, so it is repeated, no need to worry about this. Let's move. Its SI unit is Newton per Coulomb. My dear friends, its SI unit is Newton per Coulomb. Why? Force, we know E for electric field intensity, that is F by Q. Okay, so F means Newton, Q by means Coulomb, so its unit will be Newton per Coulomb. Remember, mind it. Okay, now how to find its dimensional formula? So its dimensional formula can be written as M1 L1 T minus 3 A minus 1. Are you getting? Somewhere it can be written like this also. M1 L1 T minus 2. This is what? This is force. Okay, Newton per Coulomb. So per Coulomb, so it will be written as C inverse like this. Okay, yeah. So this formula also you may get in the options, and this also you may get, right? So C inverse, yeah, you know 1 Coulomb is what? 1 Coulomb. You know? Yeah, you can write what? Yeah, so in form of current, Q is equals to IT. This formula, okay, you will learn in current electricity. So Q is equals to IT. So means this is what? Ampere, and this is time, right? So you can write like this. Okay, so here inverse is there, so that's why the formula is coming like this. Okay, that's all. So you got it, right? Either this or this, any formula is okay. You can do it. Okay, so let's move. Next I will talk about a simple question. Okay, my dear friends, so this is a very simple question in front of you. Calculate the electric field intensity which would be just sufficient to balance the weight of a particle of minus 10 microcoulomb and mass 10 milligram. Are you getting? 10 milligram is the mass. Okay, so I know one thing. Let's say this is a charge minus 10. minus 10 microcoulomb. Okay. Okay, so what will happen? Its mg will be downward, means its weight will be downward. Okay, w is equals to mg downward. After that, in upward direction, it should face a electrostatic force, means QE should be in upward direction. So what will happen when it is possible? Simply speaking, if this is a negative charge, right, and I want it to be I want the force in upward direction, repulsion force, then I need to give the electric field. I need to give the electric field in which direction? So I will give the electric field in which direction? You know, in downward direction. Why? If electric field is in downward direction, so negative charge will be opposite to the electric field. It will experience force opposite to the electric field, and positive charge will face the force in same as the electric field. Like this is positive charge, so electric field is in this direction, so force will be in this direction. If this is a negative charge, so if electric field is in this direction, then force will be in opposite direction. So that's why I am saying if electric field is in downward direction, okay, this is weight, electric field is in downward direction, this is a negative charge, so it will experience a force F is equals to QE in upward direction. Okay, so let's use it. So I will simply say F is equals to Q into E, right? And that will be equal to mg. Mg means what? 10 milligrams. So here I am writing m into g. Okay, yeah. So QE minus 10 into 10 raised to minus 6 microcoulomb, you know? After the electric field is E, and after that what I will write? I will write here m into g. So let us write just its magnitude. Okay, I am just writing its magnitude. So is equals to m into g. So mass is 10 milligrams. So 10 milligram means, let us convert in kgs. So 10 raised to minus 6 into g. This is 10. Okay, this 10 will cancel with this 10. Okay, and what we are getting? We are getting E is equals to 10 Newton per coulomb. In which direction? So in which direction? So downward direction. Okay, so the answer is electric field should be in downward direction and it should be 10 Newton per coulomb. Okay, are you getting? Instead of negative charge, if there is a positive charge, then electric field should be in upward direction. Okay, that's all. This is a simple thing, simple application I wanted to explain. Okay, thank you. So let's move to the next question. Yeah, okay, let us talk about some basic formulas. My dear friends, now I am going to talk about some basic formulas which are very important. Okay, the first thing, I am taking point charge. Okay, electric field due to a point charge. So let us talk about a point charge. Okay, so let's say I have a point charge. So let's say this is a point charge Q. What will happen? So this is a point charge, so around this the electric field will be always in a region like this. Okay, like a circular region it will form. Okay, so I am saying, let's say here is a point. So let's say this distance is r. What? R. Okay, what will be the direction of field? So due to a positive charge, direction of field is always away from the charge. Okay, so how to write? E is equals to kq divided by r square. Are you getting? Kq divided by r square, and this is the direction is what? R vector actually. So I will say here I will write r cap, kq r cap divided by r square. Okay, r cap, what it is showing? This is just a unit vector in the direction of from charge to the point. Okay, yeah, so it is just indicating the position of the point with respect to q charge. That's all, my dear friends. So kq upon r square, r cap, and it is also can also be written like this, kq upon r cube, and this is r vector. Okay, how? Because r cap is equals to r vector divided by its magnitude. So all of you know this. Okay, that's all. So this is the formula of electric field. I am using here vector form. Okay, just magnitude you want, then kq by r square. That's all. Okay, r is the distance of the point from the charge. That's all. Clear? So this is due to a point charge. Okay, so first thing is over, and let us talk about its curve. So I will say electric field. Yeah, here I can say k constant, q constant, and r square is variable. So I will say E is inversely proportional to r square. Whenever E is inversely proportional to r square, so I already explained in my lecture, let's play with graph. This inverse relation always gives a rectangular hyperbola. So the curve will look like this. Okay, so E versus R curve will look like this, my dear friends. Okay, so this is a simple basic curve and you can do it, right? Done, my dear friends. All of you can do it. Next, second number. Number 2. First is over, right? First one is over. Let us talk about second. Second is infinite long charge. Okay. So next I am talking about infinite long charge. Infinite long charge. Matlab, what is the meaning? Its meaning is, I can say infinite wire. Okay. Line charge, we can say. Line charge. Line charge or wire. So it will look like this. So this is a wire. Okay. And it is infinite long. Okay. So what I will say, I will not say its charge is q. I will just define its charge, linear charge density. What? Linear charge density, lambda. This symbol is called lambda, and it is what? Charge per unit length. Okay. If I want to find the electric field intensity at this point, or let's say at this point, okay, so always it will be away from the line charge and perpendicular to it. So it will be like this. So this is the direction of electric field. Or what will be the formula? Remember, let's say this distance is r. Okay, so I will say E is equals to, directly we will write the formula. What? Lambda upon 2 pi epsilon naught r. Okay, or if you want to write the direction, so you write here r cap. Okay, and the another formula you can write what? 2k lambda in form of k, and in terms of k. So 2k lambda by r into r cap. So this is the simple thing. All of you can do it, right? What is the value of k? 9 into 10 raised to 9. Okay, yeah. And what is formula? 1 upon 4 pi epsilon naught. Okay, that's all. So 2k lambda upon r and r cap, right? That's all. So this is the formula for the infinitely long line charge. Okay, so all of you can do it. Next, how will be its curve? How the curve, yeah, electric field will vary. So let us show its curve. E is there, r is there, and I know E vector is inversely proportional to r. Are you getting? E means field intensity is inversely proportional to r. So whenever E is inversely proportional to r, inverse relation means again rectangular hyperbola. Are you getting? Again rectangular hyperbola. Whenever inverse relation is there, there will be a rectangular hyperbola. Then you will ask, sir, what is the difference between the point charge and this curve? So I will say that both are almost same, but the curve will look like this. For point charge, it will for point charge it will look like this, and for this wire, yeah. So for wire, it will look like this. Are you getting? So it will be little downward. Okay. So you got it, right? That's all. It will be little downward. That's all. Okay. Yes. So let's move to the next slide. Next formula, my dear friends. So let us talk about next formula. Two formulas we have studied. Next, number 3. So I am going to talk about formula number 3. Okay. Next is infinite non-conducting thin sheet. Infinitely large thin non-conducting sheet. My dear friends, conducting, non-conducting, different things, hai na? So I will talk about conducting also. Let us talk about non-conducting first. Non-conducting sheet. Okay, sheet means what? Plate, we can say. So it is non-conducting. So you know the property of non-conducting sheet. What is that? Let's say this is a sheet infinitely large. Okay. Yeah, a non-conducting sheet is having a charge distribution. Okay, so let's say there is a uniform charge distribution in the entire area. Okay, so I will say, let's say its charge density is sigma. What? Sigma is the charge density. Sigma means what? Charge per unit area, we can say. So sigma is charge density. That's all. So I will say, let's say there is a point. So at this point, what will be? Doesn't matter what is the distance of the point. Doesn't matter. So I will say E is equals to sigma upon 2 epsilon naught. Sigma upon 2 epsilon naught. Remember, if you want to write the direction, what you will say? Simply, you will say it is perpendicular to the area of the plate. So here we can write n cap. What? N cap? N cap means if this plate is in xy plane, then the direction of field will be in z direction. Okay, if it is yz plane, then direction of field will be in x direction. Okay, Yes. If here is a point, so I will say the field direction of field will be like this. Okay. That's all. So this is the simple thing I wanted to explain you. That's all. This is because of a non-conducting sheet. Non-conducting sheet. Sigma upon 2 epsilon naught. Okay. Let's say, let's say this. Sorry. Let's say this sigma is not given. Okay. And this is some sheet. Let's say this is some sheet, not infinite, but sheet of area A. Area A. Okay, sheet of area A is there, and any point is near to that sheet. So any point is given near to this sheet, and let's say charge on this is Q. So what will be the electric field at this point? So I will say electric field will be Q. Sigma can be written like this. Sigma is equals to charge divided by area. So Q by A. 2 epsilon naught is already there. So Q upon 2 epsilon naught n cap. That's all. So remember this formula. If charge is given, then Q upon 2 epsilon naught. If charge density is given, then sigma upon 2 epsilon naught. This both formulas are same only. So no need to worry about that. Just remember. Mind it. Important. Okay. So how the curve will look like? So let us draw the curve. I'm saying ki this electric field intensity does not vary with distance. This is a constant value. This is a constant value. So its value will be like this, constant only. What? Sigma upon 2 epsilon naught. So the constant curve we will get. Okay, that's all. This is the answer. Okay, so I think you are getting it very well, right? Yes. So this is the third formula I wanted to explain you. Next I will talk about the uniformly charged ring. After that I will come to the conducting sheet. So let us talk about the conducting sheet. You know, number 4 I will discuss about the conducting sheet. So next, number 4 I will discuss about conducting sheet. Conducting sheet. Conducting thin sheet. So remember one thing, always you need to remember, if I am giving some charge to this sheet, so it is having two surface area. One surface area is this side, another surface area is this side. So this charge Q will distribute uniformly at both the sides, any both the surfaces. Okay, because if it is non-conducting, then charge will remain at the surface, right? Okay, yeah, it is fixed. But it is conducting, then charge will go at the surface. So the if we will talk about charge density, you know, in the last part for non-conducting sheet, only charge divided by area. That's all. Charge divided by area. Okay, that's all. But here I will say there are two surfaces, A area this side and A area back side. So I will say ki this charge will go at this side and that side. So sigma, sigma. Okay, are you getting? Yes. So I will say electric field intensity E will be at this point, right? At this point electric field intensity E will be, because of this sigma, it will be sigma upon epsilon naught, sorry, 2 epsilon naught. Okay, and because of this charge also electric field will be in the same direction only, and that is sigma upon 2 epsilon naught. Okay, definitely you will be having a doubt here. Okay, I'll clarify that. Okay, so this is sigma upon epsilon naught. Okay, remember, so electric field intensity due to a conducting sheet is sigma upon epsilon naught. Okay, how? Listen, this is a sheet, so I will consider there are two surfaces. Because of one surface at this point, the field is sigma upon 2 epsilon naught. Okay, yes. So this is because of one side, and there is another side, back side. Okay, so back side also sigma. So because of that also the field will come here, that is sigma upon 2 epsilon naught. So again sigma upon 2 epsilon naught. So both of these are added and we are getting sigma upon epsilon naught. Okay, so here we will use n cap. N cap means perpendicular to the area. Okay, means perpendicular to the surface, है ना? Yes. So that's all you need to remember. This is the formula, sigma upon epsilon naught due to a conducting sheet. Okay, yes. So in form of charge, what you will get, my dear friends, listen, very important thing. In terms of charge, if the charge on the charge on the plate is given, then how you will write? So listen, let's say this is a conducting sheet. I am giving a charge Q to it. If I am giving charge Q to it, then what will happen? Q by 2 charge will be this side and Q by 2 charge will go this side, because charge will distribute on entire surface uniformly. So one surface this side, one surface this side. Okay, so let us write electric field at this point. So E is equals to Q by 2. You know the formula. because of charge q, the electric field intensity was q upon 2a epsilon naught. But here charge due to one side is q by 2, so q by 2 upon 2a epsilon naught. Okay, plus q by 2 upon 2a epsilon naught. So what we are getting, finally we are getting, add this both, q upon 2a epsilon naught, q upon 2a epsilon naught n cap. So you can see, for conducting sheet or for non-conducting sheet, in terms of charge, formula is same, q upon 2a epsilon naught. But in terms of charge density, formula is different, sigma upon epsilon naught. Here sigma upon 2 epsilon naught. Are you getting? So I am saying the formulas are same only. Okay, just for conducting sheet it is sigma upon epsilon naught, and for non-conducting sheet it is sigma upon 2 epsilon naught. Okay, in terms of charge it is given, then for both conducting and non-conducting, the we will get the formula E is equals to q upon 2 epsilon naught. Okay, are you getting? So obviously this value of sigma for conducting and non-conducting will be different, है ना? Will be different. Okay. Yes. So that's all. Anyhow, value will be same only, right? So are you getting? Right? If q charge is given to a conducting sheet, then the electric field intensity will be q upon 2 epsilon naught. If q charge is given to a non-conducting sheet, then also q upon 2 epsilon naught will be the electric field. Okay, same formula. Just in terms of sigma it will be different. For conducting it is sigma upon epsilon naught. For non-conducting it is sigma upon 2 epsilon naught. Okay, that's all. Yes. So how will be the curve? The curve will look like this. My dear friends, I am drawing the curve. So this is E, this is R, and curve will be like this. So this I can write what? Sigma upon epsilon naught. Okay, constant curve. Okay, that's all. So next I will talk about ring, uniformly charged ring, uniformly charged. My dear friends, all formulas will be revised here, no? So no need to worry. Uniformly charged ring. If I am talking about uniformly charged ring, what I will write? So listen, let's say this is a ring, this is its center, and this is its axis of the ring. Okay. Yes. So let's say the radius of this ring is r and charge on this ring is q. Okay. So capital R is its radius. Okay. Now what we can do? Let's say there is a point at a distance x. Here electric field will be like this. Why? Because of this point electric field will be in this direction. Because of this point electric field will be in this direction. So perpendicular to axis components will be cancelled. The net will be in this direction. The electric field will be in this direction. Okay. How to write it? So we can write it like this. E is equals to kqx upon r square plus x square raised to 3 by 2. Okay, are you getting? Or you can write it like this also. E is equals to kqx upon r square plus x square cos theta. Okay, so doesn't matter. Remember this formula, you can do it very well. Okay, yes, that's all. So what is cos theta? Cos theta you can write x upon root of r square plus x square. So the same value you will get. Okay. Yes, so this is the formula you need to remember. Okay, yeah. So how it vary? Let us talk about its curve. How its curve will look like. Okay, this is the formula you need to remember. No need to go for derivation. Anyhow, it's simple only, but still no need to go for its derivation. Okay, just remember the formula. For NEET, formula is enough. Remember kqx upon r square plus x square raised to 3 by 2. How the curve will look like? Listen. Let's say ring is placed at origin. So let's say this is y-axis and this is x-axis. So ring is placed at origin. Origin is this. Okay. So at the center, electric field intensity will be 0. Why? You can see, if this is a ring, then this will be the direction. All will cancel, right? All will cancel each other. From all directions, it will be cancelled at the center. Okay. So this is, I will say, electric field intensity. This is r. R means distance. Means we can say here it is x. Okay. How you can write? So the curve will look like this. Listen. Let me draw the curve. Okay. And here the curve will look like this. Okay. So same type of curve, but in opposite direction. Okay. All of you are getting it very well, right? Because this left direction is negative direction. That's why this curve is downward. Okay. and right direction is positive direction, so positive value of electric field, it is upward. Okay, yeah. And this peak will be at x is equals to root of sorry, r by root 2, where r by root 2 means maximum value of field will be x is equals to r by root 2. Okay, that's all. So this is the formula you need to follow for a uniformly charged ring. Very very important. Okay, remember whatever formula I am telling you, right? uh, these are very very important. You need to remember at any cost. With curve, curves are also important, because many times in exam you will get the curves and you need to identify, and you will get confused. Oh, why I forgot, why I did not listen that lecture, why I ignored that. Okay, so let us talk about the next. We already discussed the infinite charge sheet, conducting sheet we have discussed. Next, let us talk about uniformly charged holosphere. Okay, so next I am going to talk about yeah, this all things we have discussed, right? This is number 5, this is number 5. Okay, and let us talk about number 6. Number 6 I am talking about uniformly charged holosphere. Holosphere is also called shell, you know. So uniformly charged holosphere. So let us talk about this. So I'm going to draw a holosphere. So this is a holosphere. Let's say its charge is q. So it is having charge q, positive charge. Okay, what will happen? So we know this is the let's say radius r. Okay, so the direction of field will be perpendicular to the surface and outside, right? This will be the direction of field, right? Okay, so I will discuss about some points. At first I will discuss about outside. Okay, outside. So electric field outside means r. Let's say that point is here. So this is, let's say, r. So at this point r is greater than radius. Obviously, if the distance of the point is greater than radius, means it is outside. So the formula of the field will be E is equals to k q upon r square r cap. Okay, vector form, it is not necessary at all the places. It is according to our requirement. Okay, just magnitude if you will talk, then you will write kq by r square. That's all. Next, second formula at surface. So what will happen at surface? At surface, small r is equal to capital R. If small r is equal to capital R, then replace the small r with capital R. So what you will get? kq divided by r square. Okay, are you getting? That's all. And the direction will be along the radius, so you can write it r cap. Okay, it is just representation. R cap, unit vector means with respect to the charge, we are just writing the position vector, unit vector of the position vector of the point. Okay, next, third, inside. My dear friends, always remember, inside it is always 0. What? 0. Here I am writing 0. Electric field intensity at any point inside the shell will be 0. Remember, because at any point from all the directions, the electric field will cancel each other and it will become 0. Okay, yeah. So remember, at any point outside a holosphere, right, the holosphere will act as a point charge. A holosphere act as a point charge. Then that's why we are getting the formula like this, kq upon r square. So how the curve will look like? Listen, the curve will be like this. This is E, this is R. So from r is equals to 0 to r is equals to capital R, means till the surface. So it is 0. So I will say this is 0. Okay, so this is 0. After that, from this point, the curve will look like this. Uniformly, I will say rectangular hyperbola, we can say inversely proportional to E is inversely proportional to r square. Here E is 0. So what is this value? This value is kq upon r square. Okay, yeah. So the curve is here from 0 to r, and after that from this point to this point, curve is like this. Okay, that's all. So this is over. This is the curve for the holosphere. Remember, you need to remember, you have to remember, you have no other option. Okay, yeah. Up here I will talk about, this is what uniformly charged holosphere. It may be conducting, it may be non-conducting. Okay, after that, here one more thing I will talk about. that is conducting solid or hollow, conducting solid or hollow sphere. So whenever there is a conducting hollow, or yeah, this is what, this is non-conducting hollow sphere. Okay, if there is a conducting solid or hollow sphere, then what will happen? Yeah, so what will happen? So I am saying ki whatever charge is given to it, that entire charge will come at the surface, because conductor is having a property that entire charge will go at its outer surface. Okay, so entire charge will go at its outer surface. So this will behave as a hollow sphere. What? Even it is solid sphere, even it is solid conducting sphere, it will behave as a hollow sphere. So all formulas will be same for this, remember. So what are the these formulas are applicable for what? Non-conducting, non-conducting shell or hollow sphere. Are you getting? After that, it is applicable for conducting shell or hollow sphere, and after that it is also applicable for conducting solid sphere, conducting solid sphere. So remember, these are the three shapes for which these formulas are applicable. Okay, that's all. Yes. So one more thing is remaining, है ना? So for that I need to erase something. So we'll erase, right? These things you remember. Okay. Yes. So I think you are getting it very well, right? So next I will talk about some more formulas, right? Some basic formulas are remaining. So let us talk about those. So I'm going to erase this all. Okay. So next I will write number 7. Number 7, I will talk about uniformly charged solid sphere. If there is a uniformly charged solid sphere, what will happen? Okay, let us talk about this. If there is a uniformly charged solid sphere, but that should be non-conducting. What? Non-conducting. Remember, my dear friends, non-conducting. If there is a conducting solid sphere, then it will behave as a hollow sphere. But if it is non-conducting sphere, then charge distribution will be in the entire volume. Okay. Yes. So its radius is, let's say, r, and total charge is q. So how the formula? How we'll write the formula? First formula. Outside the solid sphere. The outside, how we'll write? All of you know. Outside means r is greater than capital R. Means it is greater than radius. Outside point. है ना? Yes. So E will be equal to KQ divided by R square, and we can write it R cap. Okay. Why? Because entire solid sphere will behave as a point charge placed at its center. Okay, remember, for a uniformly charged solid sphere, it behaves as a point charge placed at its center. Next, at the surface. So what will happen at surface? R is equals to capital R. So what I will write? E is equals to, E is equals to, I can write KQ, and small r is replaced with capital R, so R square. And direction, if you want to write R cap, you can write. Okay, that's all. After that, the third E inside. My dear friends, it is very important formula. Let us talk about inside the solid sphere. Means R is less than capital R. The formula will look like this: E is equals to K Q R upon R cube. Remember, KQR upon R cube. This is the formula you need to remember. In vector form, how you will write? In vector form, you will write like this: E is equals to KQR divided by R cube. How you are getting like this? So let's say this is a solid sphere, and here is the point. Okay, here is the point. So I will say entire solid sphere, so I will consider a small sphere here. Okay, now I am saying this outside sphere will behave as a shell, and this inside sphere is behaving as a solid sphere. So only because of this small sphere, the electric field will come and its value will be like this. Okay, that's all. Okay, so how the curve will look like? So let us see the curve. The curve will be like this: E and this is r, electric field, and this is the position vector of the point. Yeah, so I know one thing. Let's say this is small r is equals to capital R, means inside the shell, so relation is what? E is proportional to r. So I will write like this. The curve will look like this. The curve will look like this. E is proportional to r. Okay. After that, the curve will look like this. This is E is inversely proportional to r square. Okay, that's all. So this is the answer. Okay, this is the curve you need to remember. You don't have any other option, right? Curve is quite simple. First straight line, right? And second is rectangular hyperbola, means inverse square relation. Okay. Yes, so let me draw it again here in a proper manner. Yeah, like this. Okay, that's also, this is the curve you need to remember. So this is the formula when you are having the electric field intensity in terms of charge, okay. If you are getting this in terms of charge density, then what will happen? Let's say charge is not given, charge density is given. Okay, if charge density is raw, charge density is raw, it is given, then what will happen? How you will write? So remember, first formula, E out, we can write it kq upon r square. So q can be written like this, my dear friends. Q can be written like this. Q is equals to density into volume. So charge density is raw into volume. Volume is 4 by 3 pi r cube. Okay, 4 by 3 pi r cube. Okay, and k can be written as 1 upon 4 pi epsilon naught. So finally, what formula you are getting? You will get raw r cube upon 3 epsilon naught, raw r cube upon 3 epsilon naught r square r cap. Remember, this is the formula you need to remember. Okay, right? I think you are getting it. You need to remember raw r cube upon 3 epsilon naught r square. This is the formula in terms of charge density. At surface, what you will do? So at surface, ES at surface, raw, small r square is given, right? So it will become what? It will become capital R. So capital R square cancel. So we can write like this, raw R upon 3 epsilon naught, and here you can write r cap. Okay, raw r upon 3 epsilon naught r cap. Yes. Next, E inside the solid sphere. So that is very important formula. How you can write it? Yeah, here you can see the kqr upon r cube. Here you will write the formula. The r cube will be cancelled. 4 pi cancel. So you will get the final formula, raw r upon 3 epsilon naught. This is very important formula you need to remember. Okay, so this is inside the solid sphere. So these are the another 3 formulas. These are also very important. You need to remember at any cost. Okay, so here I have given the formulas in terms of, charge and in terms of charge density. So you need to remember. Okay, that's all. So this is very simple question. All of you can do it, right? So don't hesitate. You need to remember. I'm simply saying just make a formula chart and stick it on your table. Whenever you are free, just read it. Okay, so it is easy to remember. You will never forget. Right? So this is formula number 7. Next, formula number 8 I will talk about. Let me erase this. Yes, so I will talk about formula number 8. What is formula number 8? That is for field at the axis of uniformly charged disk. So uniformly charged disk, we can say. Okay, so it will look like this. This is a solid, obviously this is a disk, and it is, let's say, having some charge q. So what will happen? Let's say it is having charge q. Let us write its charge density, sigma. Okay, yeah, it will be better. This is the axis. Okay, for ring at center was 0, so for disk also at the center will be 0. Okay, so it doesn't matter. Let us talk about the general formula, E. Okay, let's say this distance is x and radius of this disk is r. Okay, so how the formula will look like? So it can be given as E is equals to sigma upon 2 epsilon naught, sigma upon 2 epsilon naught 1 minus x upon root of r square plus x square, sigma upon 2 epsilon naught root of 1 minus x upon root of r square plus x square. That's all. This formula you need to remember at any cost, right? So E is equals to sigma upon 2 epsilon naught. Okay, I'm just writing the magnitude. 1 minus x upon root of r square plus x square. Okay, so this is the same formula I have written. You just need to remember it. Why I have written again here? Because I think this upper formula will be hiding behind my video, right? So that's why I have written it again here. Sigma. What is sigma? Sigma is charge divided by area, and area of the disk is what? Q upon pi r square. So all of you know this, so you can replace it here. You will get this formula in terms of charge. Okay, so the same thing you can do it. Okay, my dear friends, so this is the basic formula. I wanted to explain you the electric field intensity at a point on the axis of a uniformly charged disk. Okay, yes, so that's all. So these are the simple formulas I wanted to explain you, and these are over, right? So remember this all formulas mainly for disk, ring, okay, solid sphere, hollow sphere, thin sheet, and charged wire. Means these all 8 formulas are very important. You don't have any discount. Okay, that's all. So these are the formulas you need to remember at any cost. All formulas in terms of charge density also. Okay, that's all. What is the meaning of rho? Rho is charge density, means charge per unit volume. Then you will ask, so what is sigma? Sigma is charge per unit area, total charge divided by surface area. Okay. Then you will ask, what is lambda, sir? So lambda is charge per unit length. Okay, that is for linear object. Okay. Okay, my dear friends. So next, let us talk about this question. 2-point charge is 2 microcoulomb. So here at point A it is 2 microcoulomb. At point C it is minus 2 microcoulomb. Is placed at point A and B as shown in the figure. Find the electric field intensity at point C and D. Okay, let us talk about this. So I am saying this is point C, this is point A, this is point B. Okay, this is minus root 2 position, this is root 2. So this is x is equals to minus root 2. This position is x is equals to root 2. And this position is x is equals to 2 root 2. Okay, what is the value of AB? AB length is how much? AB length is what? 2 root 2. Let us talk about AC. AC is required. At point C we need to find. So AC length. What is the value of AC? AC is minus root 2 to 2 root 2. So I can write it 3 root 2. What? 3 root 2. Okay. What is the length BC? So that is root 2 to 2 root 2 means only root 2. How much? 2 root 2 minus root 2 is what? Root 2. So yeah, everything is in meter. Okay. Yeah, that's all. Yeah. So I am giving you electric field at point C you need to find. So I am giving you option. Choose the correct option. Okay. Are you ready? So I am writing the option. Option number A is 2 root 2 into 10 raised to 3 Newton per coulomb. B minus 2 root 2 into 10 raised to 3 Newton per coulomb. C minus 4 root 2 into 10 raised to 3 Newton per coulomb. And option D 8 into 10 raised to 3 Newton per coulomb. These are the 4 options in front of you and your time starts now. What is the electric field intensity at point C? Consider this is negative x-axis and this is positive x-axis. Okay, that's all. So if direction is towards negative x-axis, then answer will be negative. Yeah, here, yeah. Okay, so you can write answer. Okay, so you need to choose the correct answer, my dear friends. Do it. This is minus 4 root 2, this is minus 8, this is minus 2 root 2, this is plus 2 root 2. Okay, so you need to choose the correct answer, my dear friends. All of you can do it. Choose the correct answer. Yes. I have written the distances, charges are given, everything is given. You can do it. What is the value of K? K is 9 into 10 raised to 9. Okay. Yes, I am giving you 30 seconds more. At point C you need to find first. Okay. Yes, I'm waiting for your answer, my dear friends. Come on, type it fast. Okay, that's all. So I'm going to write the answer now. Okay, and the correct answer is minus 8 into 10 raised to 3 Newton per coulomb. If you will ask how, then I'm going to explain you now. Okay. Yes. So you are thinking, sir, how much plain lecture this is? You are just teaching, teaching, and teaching. There is no fun. Yeah, my dear friends, fun is also important, right? Yes. For that, proper interaction is needed, right? And that can be done at Unacademy platform. Okay. So there you will enjoy my classes very well. Okay. Okay, so let us find the electric field intensity. Yeah, definitely. I know the students cannot listen a lecture for a very long time. You know? So let us talk something first. You know? I will just talk about the NEET. If you are giving NEET exam in 2020, you know, the exam is very near, right? Just 1 week remaining, you know, less than a week. Okay, just 5 days more. Yeah. So some basic points to be remembered. Even you are giving in 2020 or 2022 or 2020, these points are important. First thing, मन के हारे हार है मन के जीते जीत means your positivity will do everything. Your positivity will do everything. You know, if you have positive mind, if you have positive attitude, yes, I can do it, then definitely you will do it. Okay. If you think I can't do it, oh no, how difficult question is, oh no, I don't remember the formula, I can do it, what I will do, like that. If you think like that, definitely it's my guarantee you will forget whatever you remember. Okay. So, first thing, have confidence. Okay. Be confident. You can do it. You can do anything. Okay. Nothing is impossible. But the thing is, you should know the concept, right? If your subject is perfect, right, like you have prepared well, then you don't need to operate off anything, right? Okay. Even your preparation is not very much good, then also don't afraid, just whatever you know you do it very well. Okay. Don't take unnecessarily. Are you getting? So that's all. This is the very important point I wanted to tell you. Next, always try to attempt easy questions first. Means just by reading, if you are not getting the question, leave it, move to the next question. Okay. Yeah. At last, whenever you get the time, you come back to that question. Why? If you will attempt the difficult question first, then it is possible that you will leave the easy questions because of the lack of time. You know. Yes. So don't make negative marks. Means like negative marking is there, so don't make silly mistakes, right? Just calculate properly, you know, and be concentrated when you are giving exams. So later on I will talk about it properly, you know. Let us solve this question now. So electric field intensity at point C, so that is because of, yeah, first, kq upon r square. K is 9 into 10 raised to 9. I'm talking about for because of this a charge, you know. So 9 into 10 raised to 9 into 2 microcoulomb is charge. So 2 into 10 raised to minus 6 divided by r square. R means what? 3 root 2. So I will write it 3 root 2. So 3 root 2 square. Okay. Next, because of B is negative charge. So because of negative charge, the electric field will be towards negative x-axis. So I will write here negative sign, and that is 9 into 10 raised to 9. Q is what? 2 into 10 raised to minus 6 upon r square. R is how much? R is BC, yani ki root 2 square. That's all. So what you are getting here, you will get 3 into 3, 9, and this is 2. Okay, so this 9, 2, everything will be cancelled. You are getting 10 raised to 3 minus what you will get, 2 2 cancel, just 9 is there, so 9 into 10 raised to 3. So answer is minus 8 into 10 raised to 3 Newton per coulomb. This is the answer. Are you getting? So this is electric field intensity at point C. So if it is given in vector form, then what will be the answer? E will be minus 8000 I cap Newton per coulomb. Okay, yeah, minus 8000 Newton per coulomb I cap. That's all. So this is a simple thing. I think you understood it very well, right? You got it. Next, let us talk about the second point, that is point D. At point D I want to find. How I'll find? So I will say this is A point, this is B point, this distance is root 2, this distance is root 2, and this coordinate is 0 comma root 2, means this distance is also root 2. So I will draw the electric field, so its direction, this is positive charge, this is positive and this is negative. So because of this, direction of field will be like this, and because of this, direction of field will be like this. Okay, now what else? This direction, this r is root 2 square plus root 2 square ka root, so we will get 2. How much? 2. R is equals to under root of root 2 square plus root 2 square. So I am getting what? Root 4 is equals to 2. Right, that's all. So this angle, how much it is? It is 45 degree. So the here what I am going to do is, this is x axis, this is x axis, this is y axis. So I am saying if I will take component along this, it will be in upward direction. If I will take component of this along downward direction, so this will be cancelled with this, and its horizontal component is in this direction, and its this e, second e, its component is also in this direction. So I will say this angle is, let's say, theta, so this will also be theta, this is theta, so this is also theta. Theta is 45 degree. So finally what we are getting? We are getting 2e cos 45 degree, 2e cos theta. I getting E is in this direction, E is in this direction. So I am taking its one component this direction. So let's say this is theta, this is theta. So E cos theta because of this E, and because of this E I will get E cos theta. So total is 2E cos theta. Okay, here E sin theta upward direction, here E sin theta downward direction. So this is downward, this is upward, it will cancel each other. So finally what we are getting? 2E cos theta. Are you getting? And what is value of E? Because both the charges are same, distance is same, everything is same. So value of E is kq upon r square. So k is 9 into 10 raised to 9. Q is 2 into 10 raised to 2 into 10 raised to what? Minus 6. Divide by r square. R square means 2 square is 4. Okay. So you are getting what? 9 by 2 into 10 raised to 3. Okay. In which direction? So this direction is positive x-axis. So it is I cap. Newton per coulomb. I cap. But this is E. Actually, sorry. This is just E. Not I cap. This is just E. So E cos theta. So 2E. Value of E is 9 by 2 into 10 raised to 3. And value of cos theta. Cos theta is 1 by root 2. It is given that theta is 45 degree. Not given, but we know 45 degree. Hai na? Yes. So finally we are getting 2 to cancel, 9 by root 2 into 10 raised to 3 Newton per coulomb. I cap in x direction, right? So this is the final answer. So all of you are getting it. Very simple thing. You can do it. Okay. Yes. So let's move to the next slide. Final answer is 9 by root 2 into 10 raised to 3. Find the electric field intensity at the center of a uniformly charged semicircular ring of radius r and linear charge density lambda. Are you getting? So here such type of ring is there, right? So it is given that find the electric field intensity at the center of the ring, center of the uniformly charged semicircular ring. It is just a half ring, and its charge density is given. That is how much? Its charge density is given. Yeah, lambda. So this is the ring, okay, and this is the center, and we need to find. So I will consider, let's say this left direction is positive x-axis and downward direction is positive y-axis. I'm just considering, okay, I'm just considering, okay. So I need to find the value of field intensity at the center. So how I'll calculate? So I will just consider randomly. I will consider a small segment, okay. Randomly I'll consider a small segment. So here I'm solving it. Listen. Let's say this is a ring, this is a center. So I am saying that this ring is formed of small segments, small point charges, okay. So I will just consider a point charge, like a small segment looks like a point charge. So let's say its charge is dq. How much? Dq. Okay. So this is a very small segment, and this is making an angle. This is radius r, and let's say this is making angle theta with this direction. It is making an angle theta. Okay, so what will be the direction of field? The direction of field due to a charge is always away from the charge, like this. Sorry, the direction will be like this. Okay, this is the direction because of dq charge, so it is, I can write it is de. This angle is theta, so this will this angle is also theta. Now what I can do, so this is y-axis, this is x-axis. I will take two components, this direction de, y direction, so de sine theta, and this direction, this is positive x direction I considered, so this is dex, that is de cos theta. Are you getting? That's all. Up now listen, very important thing I am going to discuss. Let's say here I am considering a point segment, so because of this, direction of field will be like this. Here also if I consider a small segment, the direction of field will be like this. So I will say its x component ex will be in this direction, and its x component ex will be in this direction. So this will be cancelled with this, and both of their y components are in downward direction. So I will say final intensity of field will be in y direction only, x direction will be cancelled. Okay, so this is the simple thing you need to remember, my dear friends. Because of symmetry, in x direction field intensity is 0. Okay, remember, mind it. Because ring is like this, at this point if field intensity is like this, because of this point field intensity will like this. So if I will take horizontal components, so this direction and this direction, x will be cancelled with this x, so this just opposite direction, so it will be cancelled. Okay, so simply I will say due to symmetry, due to symmetry, ex, okay, yeah, I can write ex will be what? 0. Why? dx all will cancel each other, right? So ex will be equal to 0. I can write it like this also, integration of dex. Okay, right? You can solve it properly if you want. Okay, how you will solve, or how to write the value of de? So you can solve it properly. Okay, like k dq upon r square. R is the radius and this is sine theta. Okay, how you'll write the value of dq? So dq is what? dq is lambda into dl. dl is what? R d theta. All of you should remember this. Why? Because this is a small segment, this is let's say it is forming a small angle d theta, so r d theta. So here you will write and you will integrate it. Okay, as you will integrate it, you will get the 0 answer. So integration of d also you will get 0. From where to where? 0 to 180 degree. Okay, so that's all. Anyhow, you just remember this, dex is equals to 0. I am not explaining the proper derivation here for x direction, because for y direction I will explain, so you will automatically get. Okay, so let us talk about y direction. So next I will talk about in x direction you are getting 0 for y direction. So now I will talk about ey, that is integration of dey, and that is what? Integration of de sine theta. Okay, integration of de sine theta. This theta is varying from here to here, 0 to 180 degree means 0 to pi. So 0 to pi. Okay, now what you will write the value of de? So you will write like this, de is k dq up k dq sine theta upon r square. Yeah, so let us write it. This I have written for y direction only, hai na? So k, here I will write dq upon r square. Okay, and here you will write what? Sine theta. It's integration. Value of dq, what you can write? Value of dq you can write lambda r d theta. So let us write it here, k lambda r divided by r square is there, sine theta is there, and d theta. Okay, yes, so let us integrate it from 0 to pi. So integration of sine theta is minus cos theta, so I'll get k lambda divided by r, and sine theta, integration of sine theta is minus of cos theta. From where to where? 0 to pi. As you'll put the value, you'll get the 2k lambda divided by r. So this is the final formula. Okay, in which direction? It is j direction, downward direction, so j cap. Okay, In x direction it is 0, and in y direction it is 2k lambda by r. So remember, because of this semi ring, the final answer will be downward direction. So you can remember this formula also, and if you want, you can go for the proper method, but it will take your time, it will consume your time, so you should learn this formula. Okay, so remember here, listen, because of this semi ring lambda. Okay, so this is just I'm showing, this is radius r. So at this point, e net is equals to ey, and that will be equal to 2k lambda by r. Okay, that's all. Downward direction. Okay, that's all. Downward direction I have considered positive y-axis, that's why I am writing positive j cap. Okay, that's all. So this is a simple thing. Now we can compare this with the formula. Remember, let's say if there is a semicircular ring, then you can compare with infinite wire. You can compare with infinite wire, infinitely long wire. Okay, for infinitely long wire, E is equals to what? 2k lambda divided by r. Okay, so the same formula you will get for the semicircular ring or for the infinitely long wire. The same formula you will get. Okay, that's all. So what is the final answer you got? You got E is equals to 2k lambda divided by r and j cap direction, downward direction. Okay, next, yeah, here I have written the proper derivation for this, means proper solution. Anyhow I explained, but still let's see. So due to symmetry, Ex is equals to 0 and Ey is equals to dE sin theta. We can write what? K lambda by r sin theta d theta, and you are getting 2k lambda upon r. Next, yeah, here again the same question but little different. Let's say this is radius r and charge density lambda. What you will do? Again same thing, you will consider a small segment like this. This is angle theta, so the direction will be like this, dE. So here this angle is theta, so this is theta. So here dEx is equals to dE cos theta, and here this is dEy, that is equals to what? dEy, oh sorry, dE sin theta. Okay, but here I know one thing. What? This is just quarter ring. This side there is no ring, means it is not symmetry. It is not having symmetry. There is no symmetry means how you will find? So you need to find this separately. So dE is equals to, yeah, you can write E is equals to Ex I cap plus Ey j cap. है ना? This direction is x axis, this direction is y axis. Just simply. So what is the angle? This is varying from where to where? 0 to 90, 0 to pi by 2. Okay, so such we'll do that only. So let us write it. Ex is equals to integration of dEx, means integration of dE cos theta. Okay, how to write dE? So let us write dE first. dE is k dq divided by r square. Okay, k dq can be written as lambda r d theta. Okay, lambda r d theta upon r square. So directly you are getting k lambda by r d theta. Put this value in the above equation. So what you will get? You'll get Ex is equals to k lambda by r. Here you will write cos theta d theta. That's all. So from where to where? 0 to pi by 2. 0 to pi by 2. Do you know it is varying from 0 to pi by 2? Quarter ring, 1/4 of ring. That's why. You know? Yeah. So integration of cos theta is what? Sin theta. So k lambda by r sin theta. And from where to where? 0 to pi by 2. If you put the value, you are getting k lambda by r. What? K lambda by r. In which direction? So this is Ex. So this is I cap direction. Okay. Next. Similarly, Ey is equals to integration of dEy. So you will write what? K lambda by r. Instead of cos theta, here we will write sin theta d theta. From where to where? 0 to pi by 2. Okay. So as you will calculate, you will get what? Minus k lambda by r cos theta. Okay. And 0 to pi by 2. As you put the value, what you will get? Directly you will get k lambda by r. Same value. So finally, what is the answer? So you are getting E is equals to AX I cap, EY J cap. Both formulas are same. So K lambda by R is common and you are getting I cap plus J cap. So this is the answer. K lambda by R I cap plus J cap. That's all. So this is the final answer for the electric field intensity at the center of the quarter ring. That's all. Right? It is not difficult, my dear friends. Once you understood it properly, means you can do it. Okay. So this is a simple thing I wanted to explain you, and anyone can do it. If you don't want to solve that much, then remember this formula. Okay, remember this formula. That's all. Okay, agree all of you? Right. Let's move. If you are not getting in a one chance, right, in a single time, then repeat it. Means watch it again. You will get it. Okay. So it is just answer I have written. That's all. Let us talk about this question. Listen, such type of question NEET may ask you. Okay, yeah, you can see here is a positively charged plate. Positively charged plate. Okay, large plate is there, and one negative charge. Okay, let me take the laser. Yeah, so here is a positively charged plate and one negative charge is projected from the plate at an angle theta, from the horizontal. Okay, and just a minute. Yeah, then it is following a projectile path and coming back. Why it will follow a projectile path? Because charge is negative and plate is positive, and we know for a large plate the electric field is constant. So electric field will act as a gravitational force. There is no gravity. Consider there is no gravity. You know, it is written in the question, neglect the gravitational force. Particle want to go like this, but because of electrostatic force it will come back. Why? Because the plate is attracting it, so it will execute a projectile motion. What? Projectile motion. So what you will do, listen, at first let us write the value of electric field. E is equals to sigma. Okay, this is what? Infinitely large plate, so simple sigma is given. Infinitely large plate is given, you know. So simply this is sigma upon 2 epsilon naught. Whenever it is written infinitely large plate, just consider this is a non-conducting plate and sigma upon 2 epsilon naught you use. If there is written metallic plate, then you have to consider it is what? It is metallic plate, then it will be conducting plate. Okay, yes. So E is equals to sigma upon 2 epsilon naught. Okay, field is in which direction? Field is in upward direction. But I am saying ki if you consider this negative charge, the force on negative charge, F is equals to Q into E. All of you know that. So that will be in downward direction. So force will be sigma charge is Q naught upon 2 epsilon naught. In which direction? Downward direction. Are you getting? Means it will act as a gravity. Yeah, just like gravitational force it will act. So what we need to do, let's see. An infinitely large plate of surface density sigma is lying on a horizontal xy plane. A particle having charge minus q naught and mass m is projected from the plate with velocity u, making an angle theta with the sheet. Fine. Time taken by the particle to return on the plate. So time taken by the particle to come back to the plate. Next, maximum height achieved by the particle. So what is the maximum height achieved by the particle? After that, at what distance will it strike? Means horizontal range you need to find. So how you will solve? Listen, you know one thing, F is equals to ma, right? So what will be the acceleration here? Acceleration will be F by m. So what is the value of F? Sigma q naught upon 2 epsilon naught you have written, divide by m. So this is F. So this is what? This is acceleration. You got the acceleration, and in which direction? Downward direction. So particle is moving like this, it will come back. So I will say just like gravity it will work. So you know the projectile formula, time of flight. So T is equals to 2u sine theta upon g. So instead of g here we will write acceleration. Okay, so 2u sine theta upon a we need to write. Okay, this g is what in projectile motion it was gravitational acceleration. So here also it is projectile motion, but instead of gravitational acceleration it is acceleration because of that electrostatic force. So answer is 2u sine theta divide by sigma q naught upon 2 epsilon naught m. So what final answer you are getting? 4u epsilon naught m sine theta upon sigma q naught. This is the answer. Next, maximum height achieved, u squared sine squared theta upon 2g. This type of formula was there. So here what I will write? Here I will write what? H max is equals to u squared sine square theta upon 2. Instead of g I need to write acceleration, है ना? Instead of g I need to write what? Acceleration. So what I will write? I'll write sigma q naught upon 2 epsilon naught m. To cancel. So what final answer we are getting? U square epsilon naught m, okay, divided by sigma q naught, and here sine square theta. Very simple, right? Next, horizontal range, maximum horizontal distance. So that was u squared sine 2 theta upon g. So here instead of g we need to write a. So what we'll get? U squared sine 2 theta upon sigma q naught upon 2 epsilon naught m. So final answer is 2 u square epsilon naught m sine 2 theta upon sigma q naught. This is the answer. Okay, so these are the three answers we got for this question. Very simple, just the projectile motion, that's all. Okay, just instead of gravitational acceleration we need to write acceleration of the particle due to electrostatic force. Okay, so I think all of you got it very well, right? That's all. Next, my dear friends, some very good questions are there, so we need to discuss it. Definitely it is very important, so let us discuss those good questions. First, three large conducting parallel sheets are shown. Let's say their area is, let's say, capital A. Area is capital A. Okay, yeah, our charges are shown in the figure, right? And find out the electric field intensity point A, B, C and D. So consider this direction is negative x-axis and this direction is positive x-axis. Okay, yes. So remember, because of positive plate, listen, doesn't matter charge is positive or negative, है ना? We will write the direction according to the direction of field. Okay, means if it is in negative direction, then we'll write field negative. If it is in positive direction, then we'll write the value of field positive. Okay, so at first I need to find the electric field at point A. This we need to find. Okay, so because of these three plates it will come. Okay, how you will find? So I'm asking you, I'm raising three options in front of you. You need to choose the correct answer. A, B, C, D. Four options are there for you. First option, Q upon A epsilon naught, Q upon 2A epsilon naught. Next, minus Q upon 2A epsilon naught, and D option, minus Q upon A epsilon naught. These are the four options in front of you. Choose the correct answer. What is the electric field intensity at point A? Okay, I'm giving you 10 seconds. Do it fast. Okay, so time up, my dear friends. Let us solve it. How to solve it? I'm saying, let's say this is point A. This is plus Q charge, first plate. So because of this, charge will be away from the plate. So this is E1. Okay, E1. Next, here is the second plate, and that is having minus 2Q charge. So because of negative charge, the field will be towards the plate. So towards the plate means E2 will be in this direction. Okay, and third plate is 3Q. So this is a positive charge. So because of this, the field will be away from the plate. So E3 will also be in this direction. So I am saying E1 and E3 are in negative x direction. So this will be negative, E2 will be positive. So how I'll write? E at point A will be E1, okay, minus E1, sorry, plus E2 minus E3. Let us write the value. Okay, that is what all of you know. Because of a Q charge, value of field is Q upon 2A epsilon naught. Because of plate number 1, that is Q upon 2A epsilon naught. Because of second plate, yeah, this is negative, है ना? That is what? 2Q upon 2A epsilon naught. Third plate, minus 3q upon 2a epsilon naught. Okay. Yes, you know the formula, q upon 2a epsilon naught, because of q's charge, right? Why negative? Because of this charge is positive but still field is negative because direction is negative. Okay. Remember, we are writing the sign according to direction. Okay. Because electric field is a vector quantity. Yeah. So let us solve it. What we'll get? This is 2a epsilon naught. Denominator is same. So let us take LCM. So we are getting 2a epsilon naught. Here minus q, 2q and minus 3q. So minus 4 this, no, minus 2q. Okay. 2 cancel. So we are getting minus q upon a epsilon naught. Okay. Final answer is D for dog. So this is the final answer. Minus q upon a epsilon naught is the answer for this first question. What electric field intensity at point A? That is minus q upon a epsilon. Okay, you got it very well, right? That's all. Okay, second, find electric field intensity at a point B. Electric field intensity at point B you need to find. How you will do it? Okay, next. So simply speaking, this is q charge, this is point B, this is minus 2q charge, and this is 3q charge. And we know one thing, because of positive charge away from the plate, so E1 will be in this direction. Because of negative charge, it is towards the plate, so E2 will be in this direction. Yeah, E2 is because of minus 2q, and E3 because of 3q charge away from the plate, so that will be in this direction. E3 will be in this direction. So how you will write? E will be equal to what? E1 plus E2 minus E3. Okay, options I am giving you: A, B, C, D. Choose the correct option. Okay, yes. So your time starts now. You need to find the electric field at point B. That is 0 q upon epsilon naught, q upon 2 epsilon naught, minus q upon epsilon naught, and E option minus q upon 2 epsilon naught. So these are the options in front of you. Choose the correct answer. Okay, your time starts now. I'm giving you 20 seconds. Okay. Yes. I think you have done right. Answer is A for apple. 0. Okay. How? E1. E1 is what? I'm writing E1. E1 is this. Yani ki positive direction. So I will write Q upon 2 epsilon naught. Simple. E2 because of minus 2Q. It is towards positive direction only. So it will also be positive. So 2Q upon 2 epsilon naught. Remember, we never use the sign of charge. We always use the sign of direction. Okay. Remember, because of the negative charge we are observing the direction and we are using the sign of direction. Minus here 3q upon 2 epsilon naught. Finally this is what? Plus q, 2q. 3q minus 3q is 0. Answer is 0. Okay, that's all. So this is the electric field intensity at point B. Next, you need to find the electric field intensity at point C. Do it fast. Options A, B, C, D. These are the options in front of you, and I am asking you the what is the correct answer. So answer is minus q upon 2 epsilon naught. Okay. Yes. So your time starts now. Solve it. So let us start, my dear friends. This was a sufficient time. So because of this positive plate, it is away from the plate. Because of this negative plate, it is towards the plate. So E1 is like this, E2 is like this, and because of 3q, it is away. So it is also like this, 3q, because E3 will be like this, you know. Because of positive charge, it is always away from the plate, right? So what will be the answer? E at C will be equal to, I will write E1 positive, E2 negative, and E3 be negative, right? Okay. Q upon 2 epsilon naught minus 2q upon 2 epsilon naught, then minus 3q upon 2 epsilon naught. What we are getting? 3 to 5 minus 1, 4. Minus 4q upon 2 epsilon naught. What we are getting? Minus 2q upon epsilon naught. Is there an option? It is there in any option? Yes, the option is there. So option C is the correct answer for this. Okay, that's all. So this is very, very simple, right? I think all of you got this method properly, right? So let us talk about the last one, D point. You know, electric field intensity at point D. This you need to find. I am giving you options A, B, C, D. And last option. These are the four options in front of you. You need to find the electric field intensity at point D. Do it fast. You have 20 seconds. Do it fast. Okay. Done. So let us check what is the answer. At first I am saying because of this first plate, it is away from the plate. So E1 will be in this positive direction. Next, because of this second plate, so it is what? This is minus 2q charge. It is towards the plate. So towards the plate will be like this. And third, 3q. So it will be what? It will be what? Away from the plate. Yani ki E3 will be in this direction. So E1, E2 and E3 I have represented. So let us write ED is equals to E1 minus E2 plus E3. Here I am getting the proper signs, and here what I will get? Q upon 2 epsilon naught minus 2q upon 2 epsilon naught plus 3q upon 2 epsilon naught. What answer we are getting? 4 minus 2 is 2. So 2q, 4 minus 2 is 2, right? So 2q upon 2a epsilon naught. Okay, so finally what answer you will get? So let us cancel this 2 with this q. So you are getting q upon, okay, that's all. This is the answer. So q upon a epsilon naught is the answer. Okay, that's all. Done, my dear friends, right? Okay, so that's all. This is the simple question. Let us move to some good, very, very good questions. Okay, so now I will discuss just two more questions which are very, very good and very, very important. Okay, if you did it means you can do anything. Okay, so let us start. Yeah, so there are just two three more good questions are there. That's all for today's lecture. Definitely it is very lengthy lecture, and you might feel a little difficult in understanding, like you cannot tolerate a lecture for too long, right? So a figure shown as a uniformly charged thin sphere. Yeah, so in this diagram a thin sphere is shown, है ना? Of total charge q and radius r. Actually thin sphere means it is a shell. What? It is a shell. Okay, so thin spherical shell is there. Okay, and a point charge q is also situated at the center of the sphere. If there is written only sphere, then we'll consider solid sphere, but it is written thin sphere, What is thin sphere? Its walls are thin, means it is just a shell. Okay. Point charge q is situated at the center of the sphere and find the following. Yes, at first force on charge q. So remember, this is bada wala sphere and its charge is q, and here chota wala charge is q. Okay, so the question is find the force on charge q. What is the force exerted by this sphere on this charge? So I know one thing, force F is equals to q into E, and I know E inside the shell. E inside the shell is 0. So I will say force on charge q will be 0. So answer for the first question, what is the force on charge q? That is 0. Why? Because inside the shell, the electric field due to sphere is 0. So force on charge q will be what? 0. Okay. Next, second point. Means at center field is 0, right? At center field intensity is 0. So force on charge q is 0. Yeah. Electric field intensity at point A. So at point A I need to talk about. So let's say there is point A and let's say it is some distance r. So I will write what? Electric field intensity at point A due to charge q and due to complete shell. Due to complete shell. So due to charge q it is kq divided by r square, and due to this complete sphere it is what? 0. Why? Because inside a shell, because of uniformly charged shell, inside a shell field intensity is 0. So this is 0. Okay, only because of charge the field intensity will come. Because of shell there will be no field intensity. So answer is kq divided by r square. Okay, this is the answer. R means AC square. Okay, I'm just considering AC is equals to R here. For this question AC is equals to R. Next, third number question. Electric field intensity at point B. So B point is outside. So I know if B point is outside, then I will write E due to Q, and E due to sphere. Sphere will act as a point charge. Its formula we already studied, right? So KQ upon CB square. CB I am considering, let's say CB. Let me write CB only, plus KQ upon CB square. So what is the final answer? KQ plus Q upon CB square. CB, maybe its value is given in the question, so you need to use that. Okay, yeah, that's all. This is the answer. Yes, here R is what? R is AC, yeah. So that's all. This is the answer, my dear friends. You can do it. Very easy. Question number 8. Two concentric uniformly charged spherical shells of radius R1 and R2. R2 is greater than R1 is given. In question it is given R2 is greater than R1. Means outer radius is R2, inner radius is R1. This is a shell. These are two shells, concentric. Have charges Q1 and Q2 respectively. Derive the expression. Actually you just need to write the formula. No expression you need to derive. Just write the formulas. First, R is less than R1 means the point is inside the chota wala shell, inside the small shell. So what you will write? Inside a shell. So E is equals to what? 0 because of outer and 0 because of inner. Because of both the shells it will be 0, finally 0. Why? Because it is the innermost point inside the shell, inside both the shells. So there will be 0 electric field. Second number, R1 or R2 means point is like this. Point is here. So I will say it is outside the small sphere, small shell, and inside the large shell. So I will say E is equals to, because of inner shell I will get what? K Q1, its charge is Q1 upon distance square R square, plus outer shell, that is 0 because that is inside the outer shell. Okay, so final answer is what? K Q1 upon R square. Third one, R is greater than equal to R2. So I will write E is equals to K because of inner shell. So K Q1 upon R square plus K Q2 upon R square. So what is the final answer? You are getting K Q1 plus Q2 upon R square. Why? Because it is outside both the shells. That's all. So this is the answer. Okay. So very simple question. All of you can do it. Now the Brahmastra is coming. Very important questions. Okay. Find the electric field at point A, B and C if charge density is rho. Okay. So at point A, B and C you need to find the electric field intensity. So how you will find? at any point electric field intensity, how you can find? You can see there is a sphere, and inside that there is a cavity. Okay, the center of the sphere is O and center of the cavity is P. Now what you will do? Electric field intensity at any point, how you will write? E is equals to E complete sphere minus E cavity. Means E due to complete sphere minus E cavity. Means you consider first the complete sphere, find the electric field intensity at a point. Okay, after that, because you have considered the complete sphere, so cavity there is no charge, right? You need to minus that particular parts. Okay, so that's why we are doing like this. Okay, yes, so let's do it. Find electric field intensity at point A, B, C, D. So first question, electric field intensity at point A you need to find. Okay, let's do it, my dear friends. Very important concept. Okay, please be focused while doing this question. You know, very important. So electric field intensity at point A, how I will write? E at A is equals to E due to complete sphere minus E due to cavity. That's all. Remember one thing, inside, if the point is inside the sphere, then E will be rho r upon 3 epsilon naught. What? Rho r upon 3 epsilon naught. Remember this formula. So let us solve about this. You can observe in this diagram, you can observe point A is inside the bada wala sphere, big sphere, and A point is inside the cavity also. So for both we can apply rho r upon 3 epsilon naught. Okay, so let us find it. EA is equals to rho. Okay, r is distance of the point from the center, so I am writing OA vector, O to A, है ना, because of big sphere I am writing, है ना, so rho OA vector divided by 3 epsilon naught. Why OA vector? Because distance of point A from O is OA, and in vector form OA vector we need to write, minus because of cavity, so cavity from center of the cavity is P and point is A, so PA vector, so rho r upon 3 epsilon naught means rho PA upon 3 epsilon naught. Okay, now how we will solve it? Rho upon 3 epsilon naught common, we are getting OA, and this is PA, है ना, so OA minus PA can be written as plus AP. Are you getting? Minus PA can be written as plus AP. So finally what you will get? You will get rho upon 3 epsilon naught, and all of you know one thing. What you know? You know that OA plus AP is OP vector. So you are getting OP vector. So final answer is rho OP vector upon 3 epsilon naught. So you can see very important thing. Listen. This is P. This is A. So direction of field is at point P is like this, and direction of field at point A is also like this. OP vector means it is parallel to the center. Are you getting? At any point inside a cavity, the direction of electric field intensity is in the same direction. The line joining the center of sphere and cavity. Okay, line joining the center and cavity. Okay, so you need to remember this. Very important. Such type of question you may be asked in the theoretical question also. Okay, so you can get it in multiple choice. The direction of field is along OP vector. So means what is the direction of field at point A? So it will be given like along OA, along OP, along OP, along OC, like that. Okay, so you need to choose OP. Okay, that's all. So this is the first question. All of you should understand it very well. Very important, right? That's all. So next, number 2. Number 2. I need to erase it. Next, electric field intensity at point B we need to find. So I will say that is due to complete sphere minus due to cavity. I'll do it. E vector is equals to, due to complete sphere, I will say B point is inside the sphere, so rho r upon 3 epsilon naught formula is applicable. So rho r means OB vector upon 3 epsilon naught. This formula I am using. Okay, minus due to cavity you need to write. So because cavity is here and B point is here, so I will say what? This is P, and this point is outside the cavity. So for this I explained you the formula. E out is equals to rho. You remember that? Rho r cube. R is radius. So let us consider the radius of cavity is small r. So rho r cube upon 3 epsilon naught rho r cube upon 3 epsilon naught pb square. Pb square, or direction is pb cap. So you can write rho r cube. R is radius of that cavity. Okay, capital R is radius of big sphere. So rho r cube upon 3 epsilon naught. Okay, here you will write pb square and pb cap. Why pb cap? Because direction will be from p to b, है ना, or negative sign is there. Okay, so finally how you can write it? Rho upon 3 epsilon naught should be taken as common. OB vector is there. Okay, and I can write this minus r cube. PB cap can be written as PB vector divided by PB, means PB cube will be there. Okay, that's all. So you can write it like this. This is the answer. Okay, if you don't want to write PB, you want to write BP, you can write plus BP. Same thing, you know the basics of vector. That's all. So this is the field at point B. Okay, so this is the final answer we got for the electric field intensity at point B, right? Okay, so let's move to the next. That is what electric field intensity at point C. C is outside the sphere and outside the cavity. Okay, so I'm going to erase this. Okay, shall we erase? Sorry. So this is the last question, my dear friends. E at point C. Electric field intensity at point C is E due to complete sphere minus E due to cavity. This much you need to do. So how you will do it? Yeah. So that I will write due to complete sphere. It will be what? Whenever the point is outside the sphere, the formula will be rho into radius cube. Rho into radius cube divided by 3 epsilon naught into distance of center and point, means OC square. Or here I will write OC cap. So I can write it OC vector divided by OC cube. I can write, right? OC vector by OC cube. Why? Because this is OC cap. OC cap can be written as OC vector divided by OC. And OC square was already there, so you will get like this. So okay. So rho r cube OC vector divided by 3 epsilon naught OC cube due to cavity. So the point is outside the cavity. So rho r cube upon 3 epsilon naught. Here center of cavity is P and point is C. So PC vector divided by PC cube. So the final answer is rho upon 3 epsilon naught r cube upon OC cube. This is OC vector minus small r cube upon PC cube, PC vector. That's all. This is the answer. So this is the final answer for this question. It is not difficult. You just need to remember the formula. Okay. Yes. That's all, my dear friends. This is the answer. You can do it. Okay. Yes. So these are the basic things I have explained you, my dear friends. As I told, electric field is not difficult chapter. You just need to learn the basic formulas and its application. And I am saying ki in this lecture I have explained you all the formulas. You need to remember it very well. Okay, and after that you need to solve some questions. Then only you will get to do it properly. Okay, so that's all. After that, the electric field lines are there. So these things I explained in the last lecture also. Again, I am explaining if someone missed the last lecture. Okay, so electric field lines, what are electric field lines? Electric field lines, we can say what? Let's say there is a positive charge. So electric field lines will be perpendicular to the charge and it will always away from the charge. So it will start from the charge and it will go to infinity. So like that we can write. Okay. Yes. So like that. Okay. If there is a negative charge, then what will happen? If there is a negative charge, then the electric field intensity, direction of electric field lines will be from infinity towards charge. From infinity towards the charge, like this. Okay. Yes. So remember this basic two formulas. Okay. So these are for the isolated charges. What isolated charges means? Charges alone are placed there. Okay. So start from the charge, terminate at infinity for positive charge, and for negative charge, start from infinity, terminate at negative charge. Okay. That's all. Next point, if there are two charges, let's say there is a positive charge and negative charge. If there is positive charge and negative charge, both are placed close to each other, then field lines will start from positive and terminate at negative, like this. Okay. So here the diagram is shown, you can see, right? Starts from positive charge, terminated negative charge if two charges are charges of opposite nature are placed close to each other. If two charges of same nature are placed close to each other, so I will say plus plus. So they will not cross each other. The electric field lines will not cross each other. They will be repelled with each other from each other. So it will be like this. Okay. So it is shown in the figure. Look at this diagram. Both are positive. If both are negative, what will happen? Both are negative, then also it will repel, but the direction will be like this. Okay, the direction will be towards the charges. Yes, that's all. Okay, next, two field lines never intersect each other. That's why here the field lines are not crossing each other, these are just repelling each other. Okay, why? Because if at a point two field lines are crossing each other, means at the same point we cannot define the direction of electric field. Because what is electric field lines? Electric field lines are the curve which tangent to the curve at a point represent the direction of electric field. So at this point direction of electric field like this, at this point direction of electric field like this. So which one you will prefer? You cannot, right? So at the same point two direction of fields are not possible, so that's why two electric field lines never intersect each other, remember. Next, electric field lines never forms a loop. Okay, remember, electric field lines will never form a loop. Next, number of field lines originating or terminating at a charge is proportional to the magnitude. Definitely. Let's say I have a 10 coulomb charge and I have a 5 coulomb charge. So I will say where the electric field lines will be more. So I will say here the electric field lines will be more. Here the electric field lines will be more, and here the electric field lines, will be comparatively less. Why? Because magnitude of charge is more, means electric field is more, electric field lines are more. Okay, that's all. So this is another property, the number of field lines at unit area is more, then I will say what? The field intensity will be more. Why? Because at that point charge density is more. Okay, line density is more, means we will say what? The field strength is more at that point. Okay, that's all. If there are no lines, means field intensity will be 0. Yes, thank you very much. That's all for today's lecture, right, my dear friends? So you can comment which chapter you want to revise. Okay, so write in the comment section and I will bring the same topic for you. Use my code Rahul Dagariya, means Rahul D, Dagariya ka D. Okay, so RAHULD, and get the 10% discount on Unacademy subscription. If you are giving exam in 2021 or 2022, definitely you should buy either 1 year or 2 year subscription. Okay, so please subscribe our channel and click the bell icon so that you will get the notifications of our video. Okay, so my dear friends, simply speaking, it is very beneficial. You don't need to visit any place for the classes. Okay, and in a coaching institute, if sir gave a lecture and you missed it or you did not understand some concept, then it is missed forever. He will not explain again. But here I am available, here to explain you again and again, means I will say my recording will always be there for you, right? So definitely you are getting the best educators of the country on Unacademy platform, and you are getting the best facilities. You are getting mock tests, as series, and all things. You are getting entire syllabus, all three subjects: physics, chemistry, and maths. You are NEET students of physics, chemistry, and biology. Biology include what? Zoology and botany. So I'm saying this entire things you are getting, test series you are getting, quizzes, mock tests, everything you are getting, complete syllabus you are getting. So everything you are getting, you are not losing anything, and definitely you want to get something, you need to invest something, so simply speaking, you should buy the Unacademy subscription. There is no loss. Okay, and this is a very less fee compared to any coaching institute. For a coaching institute you need to pay 2 to 3 lakh at least for 2 years, but here we are just taking 32,400 rupees. If you use my code Rahul D, you need to pay 32,400 rupees for 2 years and just rupees 27,000 rupees for 1 year. Okay, So that's all I wanted to say, my dear friends. So definitely you can do it. You will crack NEET UG with us, and we will never leave your hand. Okay, we'll take you to the NEET, and we will crack it together. So all the best, my dear friends. Bye bye for today. We'll come soon with the next lecture. Bye bye. Good night.